Okay, we're talking about the rational zeros theorem. Let's look at another example here. So, like usual, we're going to start by writing out what is p? Well, p is either going to be plus or minus, because again, the factors of 2 would be like plus or minus 1 and plus or minus 2. So, p are the factors of 24. So they're going to be, oh, there's a lot of those. 1, 2, 3, 4, 6, 8. 12 and 24. Yikes, okay. And then the factors of q, they are plus or minus 1 and 2. I already wrote that, okay. So that means p over q, all the list of the possible rational zeros for this this polynomial f of x are going to be, it's going to be 1 over 1 and 1 over 2. It's going to be 2 over 1, so 2, and 2 over 2, which is 1. I already have that. It could be 3 or 3 halves. Okay, it could be 4 or 4 over 2, which is 2, which I already have. It could be a 6 divided by 1, which is 6, or 6 divided by 2, which is 3. I already have that. It could be 8 divided by 1, or 8. 8 divided by 2, which is 4. I already have that. 12. 12 divided by 1, or 12 divided by 2, which is 6. I already have that. Or it could be 24, or 24 divided by 2, which is 12, which I already have. So there's a lot here, right? Now I have, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's plus or minus. So I actually have 20 possible rational zeros. Now this would be really bad if I had to go and plug every single one of them in. So a tip is, if there's gonna be one in this list, it's a good idea to start with the whole numbers and start at the lower whole numbers, because why whole numbers? They're the easiest ones to plug in, and it tends to be the case in math classes that they're gonna be one of those numbers here. So let's just do that. So let's try a few things. Let's try what would be f of 1. So if we plugged in f of 1, we'd have 2 times 1 cubed minus 1 squared minus 22 times 1 minus 24. This is not going to be, I can tell you already, this is not going to be 0, because that's 8 minus 1 minus 22 minus 20. It's a big negative number, so it's definitely not that. Okay, it does tell us something interesting, which we'll talk about later. We could try f of negative 1 now, because we have to have plus and minus 1. Okay, so f of negative 1, this would change to negative 8. This would still be minus 1. This would change to positive 22. This is also not equal to 0. Okay, we can try f of 2. So f of 2 would be 2 times 2 cubed minus 2 squared minus 22 times 2 minus 24. This would be 2 cubed is 8, so we have 16 minus 4 minus 44. Oh, this is a negative number. This doesn't quite work. This is not equal to 0, so it's not 1. It's not positive 2. We can try f of negative 2. So f of negative 2 would give us 2 times negative 2 cubed minus negative 2 squared minus 22 times negative 2 minus 24. So this would be negative 16, right? Negative 2 cubed is negative 8 times 2 is negative 16. Negative 2, this would be minus 4. This would be plus 44. So we're at positive 24. Oh, subtract 24. Look, this is 0. That's great. That tells me that negative 2 is a 0, which means that x plus 2 is a factor. Right? If we're trying to factor this, it's important. Like zeros and factors are very closely related. They're the same thing, just written differently. And so this is an important thing for us to know, is that x plus 2 is a factor. Now, what do we do when we have this information? We use synthetic division. So we are going to do synthetic division with 2. Oh, sorry, not 2, negative 2, right? Because if this was x minus a, right, this would be negative a would be 2, so a would be negative 2. The coefficients of the original polynomial are 2, negative 1, negative 22, and negative 24. So let's bring these numbers down. This would be 2, this would be negative 4, this would be negative 5, this would be 10, this would be negative 12, and this would be positive 24. That's a 0. That's what we should have. That works out. So our new condensed polynomial is this 2x squared minus 5x minus 12. And we are going to just factor this. So this is going to be, we got 1 and 2 here. We got 1 and 2 here. We got 1 and 12 and 2 and 6. So it looks like we'll have to have the 6 and let's see, what is this? Oh, forgot 3 and 4. So we're going to have the 4 and the 2 and the 3 and the 1. So we'll have this 2x squared minus 8x plus 3x minus 12. So that means if I take 2x out of this first part, I have x minus 4 remaining there. And then if I take a 1 out of here, if I take a 3 out of here, I have x minus 4 here. And then that means this factors to 2x plus 3 and x minus 4. So the factored polynomial f of x is going to be my original one I found by using the factor theorem, going through this whole process using the factor theorem, and that was x plus 2. Okay, and then the next two that I just used, I just found by factoring 2x plus 3 and x minus 4. Okay, now if I wanted to, if I was asked instead to find the zeros, right? If I said instead of factor, I asked instead to find zeros, or maybe I'm asked both. Okay, well, that's a matter of just using the zero product property. So in that case, x would be -2. That's the one we found. It'd be -3/2, and it'd be +4. And wouldn't you know it, right? Like -2, -3/2, and 4 are all in this list. And so just goes to show another example where when we use the rational zeros theorem, we can factor this now. All right, let's look at this last example here. Rational zeros theorem, p's, the factors of p, plus and minus 1, 2, 5, 10, 25, and 50. Okay, the factors of q, just plus or minus 1 and 2. Okay, so that means p over q, all the possible rational zeros, are going to be 1, 1/2, 2, 5, 5/2, 10, 25, 25/2, and 50. So there's a lot of them there, but just like in the previous example, we're going to start by looking at the plus and minus, the positive and negative versions of those smaller whole numbers, because they're the easiest ones to check. So let's check f of 1 first. F of 1, if you don't know where to start, that's always a good place. Choose positive 1. So that's going to be 2 minus 9 plus 4 minus 35 minus 50. This is not equal to 0. Okay, it's also a negative number, which tells us that at 1, right, at the value, x value of 1, f of x is negative. That's something in that might be interesting later on. Okay, we also know that f of, let's try an f of -1. So f of -1, that's going to be 2, that's going to now be plus 9, plus 4, plus 35, minus 50. So look, this is 16, that's 15, that's 35, that's 50, minus 50, ooh, 0, bam, right away. That means -1 is a 0, and x plus 1 is a factor. Okay, so let's do the synthetic division here. Okay, so set this up. We've got -1 as a 0, so we bring the coefficients down. We got 2, we got -9, +4, -35, and -50. So synthetic division, we got 2, -2, -11, +11, 15, -15, -50, +50, and that's going to be 0 there, which is what we wanted. So we now have a condensed polynomial, which is this new polynomial I'm about to write times my x plus 1 would equal my original f of x. So it's going to be 2x now cubed, because I took a 4th degree polynomial, divided it by a 1st degree polynomial, ends up with a 3rd degree polynomial, minus 11x squared plus 15x minus 50. Okay, now notice we can't really factor this. We can't factor using traditional methods, so we have to go back to our rational zeros theorem. That's the only thing we can do. Now notice for this particular problem, this last number and this first number are the same as the last number and the first number in our original polynomial, so our rational zeros list is still the same list. It's possible though that after finding one of the zeros using the rational zeros theorem at first, your new condensed polynomial might have fewer possibilities to choose from out of our p over q list. So I happen to know that the next zero I'm going to be able to find here is 5. Okay, so let's plug in 5 just to verify that. So we've got f of 5, and that's going to be 2 times 125, which is 5 cubed, minus 11 times 5 squared, which is 25, plus 15 times 5 minus 50, and I know that this is equal to 0. So that means 5 is a 0, and x minus 5 is a factor. Okay, so what we've got then is that is this new synthetic division that we're going to do. We're going to do with now this condensed polynomial and 5 in the box, and our new coefficients of 2, negative 11, 15, and negative 50. Notice, and in practice, a lot of times what you can do is just write that, just do a whole nother synthetic division with 5 right away after you find the quotient of your first synthetic division problem. And you can do effectively what we're doing when synthetic division and plugging in these numbers, f of 1, f of negative 1, f of 5, it's the same thing. So you don't have to, if you prefer to just do a whole bunch of synthetic division, then you don't have to actually go in and evaluate, because it's just the same two different ways of doing the exact same thing. If we find a remainder of 0, then we found a 0. So again, let's just do the synthetic division here. 2, 5 would be 10, that's negative 1, that's negative 5, that's 10, and that's 50. So yeah, we got 0 right there. So now we have this one more condensed polynomial one more time. It was a cubic, we divided it by a first degree polynomial, so we've got 2x squared minus x plus 10. Now, this does not factor. You could try all you want to factor this quadratic and it won't work. So what does that mean? Right? Like it almost looks like it factors 2, right? Because this is a 2 and this is a 5 and this is a 1 and a 2, but we can't quite get this right. We can't have, it doesn't quite work. So what does that mean? Well, it means that the factored form of this polynomial, f of x, is just x plus 1 times x minus 5 times this quadratic, 2x squared minus x plus 10. And that's the factored form, but I also am able to still solve for x here, because even though this does not factor, I can still solve for x. And the way we do that is by using the quadratic formula or by doing completing the square. But there's even another thing that sucks about this one, and that's that it doesn't have any real zeros. So you would get imaginary numbers out, and the ultimate, the last part of this unit of like how to deconstruct a polynomial is talking about that and a few other things.